So to graph that, I made a table and I picked values for x. I can pick any number I want to pick. So I try to be reasonable, like -2, -1, 0, 1, and 2. Now let's find the y value when x is -2. What is -2 squared? That's a 4. So x is -2, comma, y is 4. When x is -1, plug into that equation. Y equals, what's -1 squared? That's a 1. So we got a -1 and 1. When x is 0, y equals 0 squared, which is 0. I got 0 and 0. When x is 1, y equals 1 squared, which is 1. That's 1 and 1. When x is 2, y equals 2 squared, which is 4. 2 comma 4. So that's how we came up with these points. I chose values for x. I didn't have to use -2, -1, and 0. I could have picked any number. But if I'm going to graph this on a graph paper, I'm not going to use 10,040. I'll need a paper the size of Texas. So I got to be careful what I choose for values for x. I don't want to go crazy with it, you know. And now let's find where these points are, plot them, and see if it works. -2 and 4. This is -2 and 4. 1, 2, 3, 4. -1 and 1. It's nice to have a graph paper. 0 and 0. 1 and 1. 2 and 4. So you can see the graph looks like this. And it doesn't stop here just because I picked these points. It keeps going. And that's what the graph of y equals x squared looks like. Notice actually the graph is really symmetric, meaning what? If I took this paper and folded along the y-axis, this side will match that side. So that's a technique I use sometimes because I don't want to pick too many points. I don't want to pick 10, 15 points to graph. If I know the function is symmetric, I'll try to find out symmetric with respect to what? In this case, this is x equals to 0. This line is symmetric along that line. But it could be any value. Let me try another one. Let's graph y equals 1 minus 3x squared. Again, make a table. So I'm going to choose values for x, and I'm going to find the y value by plugging them in this equation, and this is x comma y. And again, I'll choose some numbers, small numbers. I'll start with -2 again. When x is -2, and then I'll go maybe -1, then 0, then 1, then 2. And see what the y value. So when it's -2, y equals what? 1 minus 3 times a -2 squared. That's 1 minus, that's 4. 4 times 3, 12, -11. So -2, comma, -11. If I use the -1, y equals 1 minus 3 times a negative 1 squared. 1 minus negative 1 squared is 1 times 3, that's 3, that's a negative 2. Negative 1, comma, negative 2. When it's 0, y equals 1 minus 3 times 0 squared. 1 minus 0 squared is 0 times 3, which is 0. That's a 1. X is 0, y is 1. When x is 1, 1 minus 3 times 1 squared. 1 squared is 1. 3 times 1 is 3, that's negative 2. And when y equals 2, that's 4. 4 times 3 is 12. That's a negative 11. Did you notice anything yet? This value, when x is minus 2, gave me negative 11. When x is 2, gave me negative 11. When x is minus 1, gave me negative 2. When x is 1, gave me negative 2. It looks like the same value. So that tells me when I graph it, my function is really symmetric. We'll see if it is. There we go. Negative 2 and minus 11. Right there. Negative 1 and minus 2. 0 and 1 is right here. 1 and 2. 2 and negative 11. Notice the numbers are matching. That tells you it's symmetric. So the graph looks like this, and it continues. Again, why am I wasting my time with the 1 and the 2, or the negative 1, the negative, if it's symmetric? Why not just plot these 3 points, flip the paper over, and get the second half? Why am I wasting my time on that? So that's really a technique we're going to use. Check to see if the function or the graph is symmetric. If it is, pick only points on one side. Once you have them, flip it over, and you get the other half. But I want you to notice something here. The graph in the previous one was opening upwards, called concave upward. That's what we call this. Concave upward, opens upward. By looking at the function, I can tell if it's going to open upward or downward. You look at the coefficient of x squared. What is the number in front of x squared? It's actually a 1. If that number is positive, if a, the coefficient of x squared, is positive, it will open upward. If it's negative, notice this is the x squared. What's that number? Negative. It will open downward. That's called concave downward. So if a is less than 0, the coefficient of x squared is less than 0, will open downward. So look at the number in front of x squared. If it's positive, it's going to open upward. If it's negative, it's going to open downward. So let's take advantage of the symmetry. I don't want to pick 10,000 points. And by the way, nobody asked me the question yet. When we were in the previous section, we were solving quadratic equations. If you remember that, I still have my notes from last video. Solving quadratic equations. And we came up with 2 numbers, for example, like this, or this, or this one. We got 0 and 1, the answers. What does that mean? Well, we asked you actually when you solve a quadratic equation, tell us where does the function intersect the x-axis. And it's actually at these points. That's what you were solving for, the x-intercept. So here you have 2 answers. Here you only have 1 answer. Sometimes you have none. The function comes down before it hits the x-axis. It goes back up there. So that's really what solving a quadratic equation is. Tell us where does the function intersect the x-axis. You're finding this x value and that x value. That's what you're doing there. Just for those people interested in that. So I'm going to find out if the function is symmetric or not. It's not going to be always along the y-axis, never. So the axis of symmetry always going to be you need to find the axis symmetry. The axis of symmetry it's always going to be located x equals negative b over 2a, always. So if I have this problem, y equals 5 minus 2x squared, and I want to graph that, I'm going to find the axis of symmetry. X equals minus b over 2a. b is the coefficient of x. Since there is no x here, it's 0. Divided by 2 times a is the coefficient of x squared, which is negative 2. That's 0 over negative 4, which is 0. So the function is symmetric along x equals to 0. That means only graph one side of it. Then when you get the answer, flip it over, you know what the other half. So it's symmetric. Let me draw a line here, you can see it. It's symmetric along this line. I don't know if you can see it. So once you have that, flip it over. It says x equals to 0. That's this line. So I'm going to pick values for x. And notice the coefficient of x squared is negative, so I know it's going to be concave down, opening downward. Let me pick values for x. I'm going to start with the 0. Only going to pick one side when x is 0. 5 minus 2 times 0 squared. 0 squared is 0 times 2 is 0. 5 minus 0 is 5. So 0 comma 5. That's 1 point. Pick the 1. The y value 5 minus 2 times 1 squared. 1 squared is 1 times 2 is 2. So 5 minus 2. 5 minus 2 is a 3. When x is 2, 5 minus 2 times 2 squared. 2 squared is 4 times 2 is 8. 5 minus 8, which is what? Negative 3. So notice 3 points, that's enough. 0 and 5. See that point up there? 1 and 3. 2 and negative 3. So if I connect these points, it will look like this. Now flip that paper along that red line, the y-axis, and you should have the rest of it. So if you flip it over, you can get the other half of the picture now. And I said it's going to open downward. We were right because the coefficient of x squared is negative. It is symmetric along this line. This point, by the way, is called a vertex. And in this case, located where? As 0, comma 5. That's this point. 0, comma 5. That's your vertex. Let's try another one. Graph y equals x squared minus 4x plus the 3. Well, just by looking at it, notice the coefficient of x squared is positive. So if I make this my y-axis and this is my x-axis, I know the graph is going to open which way? It's going to open upward, like this. Why? Because the coefficient of x squared is positive. So let me find the axis of symmetry. That's at x equals negative b over 2a. What's negative? b is negative 4 over 2 times a is 1. That's 4 over 2, which is 2. So axis of symmetry, x equals to 2, which means what? If you draw a line here at x equals to 2, and you flip, once you graph one side of it, flip the function over, and you have the other half. So this is what the reflection is going to be along. So you're going to flip it over the red line. Let's take some values for x. I don't like the way it looked last time, drawing the lines by hand. Notice I'm not going to pick a lot of values. Maybe 3 will be enough. There we go. I'm going to pick values for x. Then I'm going to go to this equation, plug them in. Since my function is symmetric with respect to x equals to 2, I'll start with that value, 2, then I'll pick values above that, 3 and 4. That's plenty. So start with that number. When x is 2, what is y going to be? 2 squared minus 4 times 2 plus 3, which is 4 minus 8 plus 3. And what's that number? 4 minus 8 is negative 4 plus 3 is minus 1. So 2 comma negative 1. When x is 3, y is going to be 3 squared minus 4 times 3 plus 3. 9 minus 12 plus 3. That's a 0. When x is 4, y is going to be 4 squared minus 4 times 4 plus 3. 16 minus 16 plus 3, that's a 3. So here we go, 2 and minus 1. 3 and 0, 4 and 3. So notice the graph looks like this. We know it's symmetric, so flip it over. And that's what the graph will look like if you flip it over. It's symmetric along this red line. The vertex, that's this point. If you want the coordinates, that's 1, 2x is 2, y is negative 1. That's the first point, 2 and minus 1. That's your vertex. It's opening upward because the coefficient of x squared is also positive. It's a 1. 1 is a positive number. It's going to open upward. I'll do another one. One more. Graph y equals negative x squared plus 2x plus 3. Let's find the axis symmetry. X equals minus b over 2a. b is 2. A is negative 1. Negative 2 over negative 2, which is 1. X is 1. So when I make my table, this is the x-axis and the y-axis right there. Now axis symmetry, I'll make it red so you'll see it at x equals 2, 1. So it's going to be symmetric along this line. X equals 2, 1. So let's pick values for x. Let's use y equals negative x squared plus 2x plus 3 and write them as a point. So since the first value is 1, 1 squared plus 2 times 1 plus 3. Notice here the minus is not being squared, only the 1. So 1 squared is 1 with the minus. That's a minus 1 plus 2 plus 3. That's a 4. When x is 2 is the minus, 2 squared plus 2 times 2 plus 3. 2 squared is 4 with the minus in the front, negative 4 plus 3. That's a 3. Let me try the 3 here. 3 squared plus 2 times 3 plus 3. Negative 9 plus 6 plus 3. That's a 0. So 1 and 4. right here. That's your vertex, 1 and 4. Two and 3, 3 and 0, which means to find the other one, just flip it over. I'll have a point there, and I'll have 1 here. Notice the same distance from here to there is this one. The same distance from this red line to this should be the same to this. So my graph will look like this. And what do you know? The coefficient of x squared is negative. It does open down. Anytime the coefficient of x squared is negative, is going to open down. Anytime the coefficient of x squared is positive, will open upward. And that's the graph of this function.